Hello, I'm Patty Simpson with Simpson Math. Let's talk about the margin of error. First, in order for us to be able to use a normal distribution when finding these confidence intervals, we need to have three conditions met. First, all the possible samples of a given size have to have an equal opportunity of being chosen. In other words, we're choosing a simple random sample of whatever sample size that we're looking for. So remember when we talked about those sampling methods where every member must have an equal opportunity to be chosen? So we're using a simple random sample there to choose our sample. Then the population standard deviation has to be known. And then either the sample size is at least 30 or the population distribution is normal. So these things have to happen in order for us to be able to use the normal distribution. Now this is a little bit weird, this knowing the population standard deviation, because if we know the population standard deviation, then that means that we know a lot about that population to begin with. And so it's actually not that often that we use the normal when we're doing confidence intervals and here in a little bit hypothesis testing. But I'm going to use normal here and within our lessons just to make sure that you have a good understanding of what we're doing when we're building a confidence interval and then later when we do hypothesis testing. So now we're going to find the margin of error. And what the margin of error is for our confidence interval, that margin of error is just our number, our critical value. So we call this the critical number. And that critical number is just the number of standard deviations out that we are going in our confidence interval. So this is just the number of standard deviations. It's a fancy notation for critical number, which is just the number of standard deviations, times whatever the standard deviation is for our sampling distribution. Or you can say, well, it's the number of standard deviations out, and since we're dealing with a sampling distribution, we know to find the standard deviation of that sampling distribution, we have to do the standard deviation of our population divided by the square root of our sample size. Remember doing that with the central limit theorem to find that standard deviation of our sampling distribution. Okay, so let's do an example. A hardware manufacturer produces bolts used to assemble various machines. The manufacturer wants to estimate the mean diameter of bolts produced using a simple random sample of 36 bolts. The standard deviation for the population is known to be 12 hundredths. Calculate the margin of error for a 95% confidence interval. Okay, just making sure that it meets those three conditions. First, we've got a simple random sample that we are choosing. Second, we know the population standard deviation. We know the population standard deviation is 12 hundredths. And third, we have at least 30 in our sample size, or the population is normal. Well, we have at least 30 because we have 36 bolts. So it meets the condition for us to be able to use normal. Great. Since that, we're going to be able to find this, use our central limit theorem. Let's find our margin of error here. In order to find the margin of error now, I'm going to take my critical number, which is the number of standard deviations, times my standard deviation. Well, in order to get that critical number, or how many standard deviations out I'm looking, I'm going to look at my confidence level. This probability is really what I'm looking at. So when we see 95%, we think to ourselves the empirical rule tells us that's out 2 standard deviations. So we're just going to use that 2 standard deviations. There's more precision to that. If you go into higher statistics or if you take another statistics class, they might use 1.96 out 1.96 standard deviations. But we're just going to use 2 because this 95%, that empirical rule tells me that I'm out 2 standard deviations. So my critical number there, the number of standard deviations I'm going out is 2. Then I'm going to multiply that times my standard deviation. In other words, if I go out 1 standard deviation, 2 standard deviations, what's that distance I'm going out? How far out is that? So I just need to calculate my standard deviation. Well, I now have a sampling distribution because I've pulled a sample. So I remember to find that standard deviation of the sampling distribution, we take the standard deviation of our population and we divide it by the square root of our sample size. Now I'm just going to do some arithmetic. My margin of error is the number of standard deviations I'm going out, so 2 of them, times whatever the standard deviation is. So in this case, 1200ths divided by 6. Well, then my margin of error is 2 times, 12 divided by 6 is 2, and that 2 is out in the hundredths place. So my margin of error is going to be 4 hundredths. So what does that margin of error mean? Well, when I'm talking about my confidence interval, I'm going to use that margin of error. So when I start talking about the confidence interval, how confident, I'm 95% confident that some value, some statistic falls within this range, that margin of error is that distance out. So let's say I'm dealing with means. That margin of error is 2 standard deviations out. So in other words, I go out 1 standard deviation, I go out 2 standard deviations. This distance here is going to be 0.04. And then I'm going to do the same thing on the other end to make my confidence level where I take that margin of error and I'm going to go out 1 standard deviation, 2 standard deviations, so I'm going to go out 0.04. That margin of error is just that distance. How far out am I going in that confidence interval? So that tells you a little bit about how to find your margin of error and then what it's used for. Math Made Simple is Simpson Math. Thanks for watching.